First thing I'd like to talk about is I did make homework. I made a homework 2.1. It is 5 questions, but each question pretty much has multiple parts. WebAssign estimated that it'll take about 2.5 hours to do the assignment. And I'll show you where it is.
Wait, we have homework now?
Yeah, you have one homework assignment. It's due next week on Friday. Friday, February 4th. Okay. Oh. Again, it's due at midnight. It's 5 questions long. It's supposed to take about 2.5 hours. For each homework, I'm going to try to remember to set it up so that every problem has 100 tries. But after a few tries, stop and write a message to me or find a tutor. Okay, you can keep on trying till you get the green check mark, and then I would leave the problem alone and keep that correct answer and just fix all of the red X's till they get a green check mark and you get your full score. We'll look at it together, but WebAssign has a little message tab where you can write to me. And if you write to me there, it's much easier for me to see like what problem you're looking at. Or at the bottom of the question, it says, write your teacher, and you can write to me, and then we can both see that problem that you're having trouble with. But you can also send an email and I can help you do your homework. Okay, let's look at the website. Also, if you're having trouble creating your homework account, send an email. Maybe we can meet on Monday and figure it out together. So I'm just going to the Canvas page. Math 30. And clicking on that. Well, let's go to student. Click on the first module. I'll show you. Okay, here's our homepage. The first module has a link to the homework. The second module is for week 1, where there's the welcome back quiz, which you need to complete today so that I can write back to you over the weekend. There's the meetings from Monday, Tuesday, and Wednesday, and then I'll post today's meeting at the end. And let me get set up to show you what student screen be. Also, the homework is set to show you the correct answers after the due date. So if you need more time on the homework, write to me before it's due, so that way you can get good practice and not just know the answer. All right, here we go. Oh, we'll do that later. Okay, so here's the homepage for WebAssign. Your assignments are over here. One assignment so far, homework 2.1. It has 5 questions, and each question has 100 tries. You go down here, and I just gave this a practice run to show you that if you get it wrong, you're going to get a red X. And
Oh,
and right
wait,
here-
Cassie.
yes,
Wait, you said, is it exactly 100 tries or is there more than that?
right now it says it goes up to 100 tries on the template settings.
Okay.
I don't think I can go past, but if you want to work it out on paper, I can override the score. So, but again, if you're getting like the problem wrong a few times, just ask for help. Like up here on the top right corner of each problem, there's my notes and there's ask your teacher. So if you click ask your teacher, you can write to me for help, and then I'll see the problem you're working on and I can write back hints and stuff. Okay, so this is your homework. I'm going to explain how to do it today. Submit, save at the bottom. So save your work. And I think that's it.
Will we also be taking tests on this
No, we're going to do a tests in class.
in class? Okay, thank you.
On that note, just so no one's like super stressed, I don't allow open book or open notes during the test, but we can do test corrections. So if you get a bad score, I'll let you redo the problems to earn at most a B. I'll give instructions later. Okay, I think we introduced 2.1. I'm going to redraw this picture and then we're going to keep on working through that section. I'm going to add a little bit more to that picture. So let's say you're in a coordinate plane. And I'm going to draw a curve. So a curve is kind of more general than a function. For a function, every input has one output. But with this circle, an input right here has two outputs, this one and this one. So this isn't a function, but it is a curve. Yeah, if you have to go, that's fine. We're recording and I'll post this video tonight or tomorrow. So let's talk about a tangent line at this point x1. So it's a line that just touches the curve right at that point, one time. Okay, and then a secant line can go through the curve more than once. And they don't have to be parallel lines. I'm just talking about one that touches the curve one time and the other touches the curve more than one time. It's a straight line that just touches the curve at a point. And we'll write down the secant line of a curve is a line that intersects more than once.
I just wanted to let you know, your audio became super low.
Oh.
Yeah.
Try to fix it. I'll just try to speak up, and over the weekend I might play with using a microphone because I do have a mic. I just have to get it in here. See how.
Okay.
But thanks for letting me know.
Yep.
We're gonna draw a random.
Cassie, I can barely see the period between points and A. By like a secant line around that area. I don't see a period because it's kind of confusing, the sentence. Yeah, like, yeah, that's definitely a lot better. Thank you.
Okay, yeah. It is. So we're gonna do a sketch. It's gonna come up and over. I'm gonna pick a point right here. Let's call this X. And the tangent line will go through this point and just touches the curve right there. And it's a straight line through that point. Okay, and then let's do a secant line. We're gonna call that point P. So the P would equal the ordered pair x1 followed by f of x1. Right, we have another point we're going to call Q. So Q would be some other x value, let's call it x2, comma f of x2, written as an ordered pair. Okay. And then we're going to draw a line through P, the points P and Q. And that would be called a secant line. Just highlight. now we're going to do an actual function. It's going to be f of x. Oh, jumping through the instructions. So I have a list of how to find slopes of tangent lines at a point P. I'm going to abbreviate tangent, just tan. To a curve or function, we're going to work with functions at some point P. Okay, first up, pick another point and call it Q. By another point, I mean a different point other than P. And this point Q is close to P. There's P and there's Q, not way over here, but sort of near the point we're interested in. Actually, we're going to be picking different points. So this first point we're going to call Q sub 1. Still some point close to P. Next, draw the secant line through PQ. So it's written like, or the notation I have from the book, from my notes, is PQ1 with an arrow over it. So the line through P and Q1. And compute the slope of the line through those 2 points. Then pick another point, we're going to call it Q2, even closer to P, and then get that slope. choose closer to P. Okay, get the slope. And you keep on doing this and recording slopes of secant lines as Q sub n is closer to P. And n is a natural number. N could be 1, 2, 3, 4, 5. So we'll have Q1, Q2, Q3, Q4, Q5, and so on, Q6, and everything like that. As Q sub n gets closer to P. By the way, on your homework, sometimes at the end of the problem, it will say something like, write your solution as a natural number or as an integer or something like that, which is asking you to round up or round down to get some kind of number that they're looking for. Q sub n is getting closer to P, n is some natural number, and then I guess we could call this part 5. The value that the slopes approach is the slope of the tangent line. By the way, if you ever see like a spelling mistake or math mistake, let me know. I'm totally cool to like stop and fix it. It's gonna happen. Okay, approach, OACH. Is the slope of the tangent line. Oof. Okay, now we can do examples, or an example, where we walk through all of these steps to find the slope of the tangent line. So again, we're not getting the equation of the line, we're getting a part of that, just the slope of the equation of the line. of x is the function, where f is a function and f sends x to x cubed. Let's draw a graph.
Wait, Cassie, what happened to that other example with the tangent line and the secant line that you made before?
That's just a function that you don't know exactly what it does. It's just like a sketch of some kind of function.
Oh, wait. Oh, so that was not an example?
It is an example, but not a specific example. It's just
Oh.
like the picture.
Oh, just a picture.
Yeah.
Okay, because you put an example next to it. I thought we are gonna like try to solve it or something, but like I guess just put it there for like a example as if like how it looks like, right? A
Yeah.
visualization. Okay.
Yeah.
Yeah, just want to make sure. Yeah. I thought we are solving stuff. I'm sorry.
Oh, it's okay. I mean, like now we can because I do know what the rule is for the function.
Yes. Yes.
I know what the graph looks like. It kind of comes
Mhm.
up,
Yes.
flat, over.
Yeah. Now we're gonna write the graph, right?
Yeah.
Okay.
Thank you for asking.
No problem.
And also thank you for the students who are helping. So those are the origin. It's like growing, then it goes kind of flat, and then grows again. We want to compute the slope of the tangent line at the point 2, 8. Okay, so if you put in x equal to 2 through the function, you'll get out 2 cubed. 2 cubed is 8. We're going to come over here and kind of draw. Should probably jump up a bit quicker. And down, same way. And there. That's my point. Input of 2, output of 8. We're going to call it P. Okay. I'm going to put a side note that the slope was your difference in y values divided by the difference in x values. Let's call the outputs y1 and y2. And the input for that would be x1 and then subtract x2. Let's say this is our first point. We're going to call this x1 and y1. So I'm going to need to erase the graph so I can set up a table, and that way we can have an organized way of recording all of these slopes. But we're going to start with picking points Q1, Q2, Q3 that are getting closer to 2 from the left. So coming this way over towards 2. And we're going to start at 1, and then we're going to go closer to like 1.5, 1.9, 1.99999, as close as you can get to 2 from the left side. This here is a reminder of what our function is.
Wait, so we have to choose another point now?
I'm gonna choose the points for you, and the book sort of guides you through points to pick 2. But
Okay.
if you're doing it on your own, you just kind of want to pick whatever values you want closer and closer to 2.
It's recommended to pick something closer to your first point, right?
Yes. Let me show you.
Yeah, because if you pick something farther from that, then it's probably gonna be inaccurate because the distance probably.
Well, if you start far away, it might not be as close to the value as you're trying to know. So if you get points closer and closer, then you'll be able to see what the slope is. And I think once we work through this, you'll kind of get what I'm talking about. So just work, I guess, work with me on this notation for a second, then we'll set up a table, and then I think you'll see what I mean. I want to know the slope of the tangent line. 2, 8. Okay. So what we're doing is a table for this expression. What this says is x approaches 2 from the left. And you're going to see this throughout our semester and like in calculus. This minus sign up here means on the left side. And I made a table to keep my answers organized. And these are values for your points Q, like Q1, Q2, Q3, and so on. So values for your points that look like this. And then I put X values in. Through the function and get outputs that are called Y values. And then I did scratch work to find the slope of the secant line, which is M for slope, subscript secant, or subscript SEC. M sub secant is the slope of the secant line. So I just want to draw part of that graph that we had before. So somewhere on your number line, approaching 2 from the left side. I chose to start at x equals 1. And I want to get closer to 2. So I picked 1.5. Get even closer from 2 on the left side. So I picked 1.99. And then I stopped, and I could go closer and closer to get even better idea of what the slope of the tangent line would be. after looking at this side of the table.
I have a question, Cassie. Why does it have to be 1.99? Why can't it just be a whole number? Isn't it more simple?
It would be easier, but you're trying to get as close of a number as you can to 2.
Okay. Okay, so that close. Okay. I'll try to
Very,
figure
very
out.
close. You could put like 1.99999 and it would get even closer to 2. So we're trying to approach 2, which means pick numbers like closer and closer.
Okay.
Okay. Let's start here. X equals 1. Y would be f of 1. Through the function, get out 1 cubed. Choose 1. And then we're going to go ahead and do more scratch work and find the slope of the line that goes through the points 2, 8 and the point 1, 1. All right, so difference in y values. So I could use this y value and the y value from the other point. So I could do 8 minus 1. X value corresponding to the first point was 2, and then x value from this point would be. And then I got 7 over 1, which is 7. Let's do x equal to 1.5. So your output y is wherever f sends 1.5, and I used a calculator to get 3.375. Round up, call it 3.38. See it. And then I got the next slope, which I'll set up. You can keep that first point here, x1, y1, but now we have a new point to put in here, x2, y2, and the x value is 1.5. So we're getting a new slope for the secant line through that point and the point 2, 8. Take the difference in y values, divide by the difference in the x values, and got 9.25. one more. We're going to have x equal 1.99, and then we'll find f of x. Turns out that 1.99 cubed is 7.881.
Is it okay we just round it to 8 or
Yeah, you can round.
yeah, okay. But we could round it to 8. Do you want to stick with the decimal? Do just keep it 8?
Oh, I see, rounding up like right there. I would maybe write a few decimals, just in case.
Okay, yeah, I guess so. More accurate.
And then we do the slope through the 0.28 and the 1.99, followed by 7.88. So x1 was 2, y1 was 8. And then you've got this other point where x2 is 1.99. And the y value is 7. And I got 11.9. Okay. We're going to create another table where we approach 2 from the right. And then we're going to take information from both tables to guess what the slope of the tangent line might be. I don't know. Kind of wanted to use this picture. We'll just draw it again. Okay. So the table is another table of points Q.
Cassie, wait, and just to refresh myself, the y1 and the y2, the order doesn't matter, right? For the equation,
Yeah, you could flip this. You could do,
and it's will be the same thing, right?
yeah, look at the same slope.
Okay, just want to make sure. Thank you.
Okay, now just a minute or two. So I am going to set up what our next goal is, but we'll come back next time and keep on doing scratch work. So the next table that we're going to make are these values Q sub n, points, where x goes to 2 from the right. So you have a plus sign up here. And this says, this part, X approaches 2 from the right. Okay, let's see. I think I can at least pick. I have 1 minute. Ugh. Let me just try a quick sketch and then we'll come back and do more. The idea is 2. I already came this way with curve from this side. 1.5, 1.99, 1. Now on this side. Let's start at maybe like 3. And we'll go to 2.5, 2.01, and 2.000001. Get really close to 2. Next time I'll put in those numbers like 3, picked 2.5. We'll try doing 2.01, and then we're going to do a guess. Okay, we'll finish this table next class. Please create your homework account and start the first homework. And then just stay after if you have questions or concerns.